Okay, so here's the deal. Now we want to look into what goes into an experiment. How do we get data, okay, that's going to tell us the truth? It's tell us that what we want to know. First, let's take a look at a scientific experiment that we could perform in this classroom. So for example, let's just say we had this scientific question. How does the color of light affect the growth of a plant? That's a typo. It should say plant. So we would set something up like this, right? We'd take 4 different plants, we'd take 4 different colored lights, we'd put those plants under each of those 4 different colored lights, and we'd watch them grow, right? And then we'd measure them, and we'd look at our data afterwards, and we'd graph it, and we'd be able to tell which colored light allowed plants to grow faster, right? Cool. Well, let's talk about variables real quick. So remember, don't forget the scientific question. It's down there at the bottom. How does the color of light affect the growth of a plant? And as scientists, we design experiments so that changes in one item will cause something else to vary in a predictable way. It's how we try to answer the scientific question or problem, right? So we change something, that's the manipulated variable, and we want to watch and see what happens, the responding variable. Okay, and I got a little bit ahead of myself, but the changes are called variables. Okay, a variable is any factor, trait, or condition that can exist in differing amounts or types. Okay, an experiment usually has 3 kinds of variables. There's manipulated, there's responding, and there's controlled. Okay, so we're going to take a look at what those 3 look like. Okay, so here's back to our experiment. Remember, the question is, how does the color of light affect the growth of a plant? So first one, manipulated variable. The manipulated variable is the variables that we, the scientists, change. Manipulate means to change or to work with, or when I think manipulate, I think like manipulating clay in my hand, right? We're doing something. So what is the scientist doing, or what are they manipulating? Okay, so in this case, what are we, the scientists, doing? What are we manipulating? What are we changing from group to group? Okay, right. We're changing the color of light. Okay, that is the manipulated variable. We are in charge of that. Okay, the next kind of variable is the responding variable. Okay, the responding variable is the variable that we, the scientists, are measuring. Okay, we're measuring it because we're watching for its response to our manipulation. So we change something, we manipulate it. Okay, then we watch and see what happens. And whatever happens is the response. It's the responding variable. It's the thing that we measure. So in this case, what would be the responding variable? Okay, yeah, the growth or the height of the plant, right? That's what we're testing for, right? The question is, how does the color of light affect the growth of a plant? Well, yeah, the responding variable would be the growth of the plant. Perfect. Okay, now, what about controlled variables? Controlled variables are variables that we, the scientists, keep the same. And controlled variables are really important because controlled variables ensure that the data that we get is telling us the truth. Okay, control variables are everything that we keep the same, and the reason we keep them the same is we don't want something else to influence the results except for a manipulated variable. Remember, we're looking at only the effects of the manipulated variable on the growth of the plant, right? So we only want to know what light does to the growth of a plant. Okay? And if other things in my experiment are different from plant to plant, then all of a sudden my data could be off. It could be lying to me. For example, I might have, for this experiment, if I don't keep control variables the same, I might water plant A more than I water plant B, or more than I water plant C or D. And when I get my results and plant A grows a lot taller, I say, oh my goodness, white light helps plants grow the fastest. Well, I'm not really sure about that, because it could just be that I added more water to plant A. So I want to keep the watering the same for all the plants. So if there's any difference, I know it's from the light. Or the amount of soil, the kind of soil. Maybe I plant B in a different kind of soil than C, D, and A. And plant B grows a lot taller. And I say, oh man, green light. Green light helps plants grow a lot taller. But in reality, it could have been the soil actually that helped it grow taller because it had a unique kind of soil. I didn't keep it the same. but I'll never know. So what you need to do is you need to keep all the types of soil the same. You need to keep the amount of soil the same. Okay, and you even need to keep things like when you're taking measurements. How often are you taking measurements? Everything needs to be the same except for the manipulated variable, so that if you see a change, you know it came from the manipulated variable. You see that? Cool. So let's do a couple examples real quick. You're going to identify the manipulated and responding variables and list two possible control variables. Remember, variables that you keep the same in the following situations. So when the answer comes up, you'll see the manipulated in a blue box, responding in a orange box, and then we'll add a couple optional or possible control variables in there as well. Okay, so the first one is this. A principal wants to study the effects of caffeine on student test scores. So which would be the manipulated variable? What's the principal going to do? What's the principal as the scientist going to do? Okay, that's right, caffeine is the manipulated variable. So the principal wants to study the effects of caffeine. So the principal is going to probably give caffeine to some students and probably not give caffeine to other students. So caffeine becomes the manipulated variable. So what then is the responding variable? What's the thing we're testing? Oop. Measuring. I just blew that one. Yes, the test. Okay, the test scores are the responding variable because it's the thing we're measuring. Okay, and two possible control variables might be, you might want to give the same amount of caffeine for all the students, and you certainly want to give them the same test because you want to make sure that we know that the changes in scores isn't linked to a different test. It's all the same test. Okay. So how about the second one? A middle school student wants to find out which laundry detergent gets rid of stains the best. So which is the manipulated variable? What's the variable that the middle school student is going to change? Bingo. The detergent. Okay, they're going to try different detergents, so it becomes the manipulated variable. What about the responding variable? What's the thing that we are measuring or observing for our data? Well, the getting rid of stains. It's kind of a little vague, but that would be it, right? So the responding variable is, does the stain disappear? Does it stay there? The getting ridness of stains becomes the responding variable. So what might be a couple control variables? Okay, I put same type of material that you put the stain on, and I put same amount of detergent used. Okay, because if I put a lot of detergent on one piece of cloth and a little detergent on another, my results may suggest cloth A or the detergent A did a better job, but it could have just been because I put more detergent. So you always want to have the same amounts. Okay, control variables are very important. Okay, good. So that's variables. In a second here, we're going to look at how to do the if then because hypothesis. And if you understand variables, the if then because hypothesis is actually very simple.